Okay, consider the function f of x is equal to ln 4 minus x squared. What is the domain of this function? So remember, ln 4 minus x squared is the same as saying log base e of 4 minus x squared. So it's a logarithmic function, and I have to recognize that my argument has to be greater than 0. So let's look at this. 4 minus x squared has to be greater than 0. And so I go about solving this. Negative x squared has to be greater than negative 4. And if I divide both sides by negative 1, I got to remember to flip that inequality sign using my inequality rules. So x squared then has to be less than 4. And then you kind of can think about this logically if you wish. When you square a number, it has to be less than 4. So where would that be true? And that would be true between negative 2 and positive 2. If you think about the graph on this, now I'm just thinking about the little argument piece of the graph. This is a parabola, negative x squared plus 4, an upside down parabola. So for this part to be true, we need to be greater than 0. So where are we above the x-axis? And it would be between those x-intercepts of negative 2 and 2. How do I know those are my x-intercepts? I could just factor. So 2 minus x, 2 plus x has to be positive. If you were to do this algebraically through case analysis, which you would have learned in 20-1, we would have gone to this factored form and we would have said, okay, so in order for two numbers to be multiplied together and give me a positive output, I would need to either both factors to be positive or both factors to be negative. So 2 minus x would have to be greater than 0. And is our upside down u. 2 plus x would have to be greater than 0. So then negative x has to be greater than negative 2. X would have to be less than 2. And then at the same time, I need x to be greater than negative 2. So think about what that looks like on a number line. This is just case 1. Okay, so here we go. I would have that I would need to be less than 2 and greater than negative 2. But the catch here is this and. It has to be true for both. So where's the overlap? Okay, where's the overlap? The overlap's happening in between negative 2 and positive 2. So this first case is giving me the same answer I kind of solved by logic over here or from my graph. So what about case 2? Case 2 would have said that they both would have had to be negative in order to get a positive output. Okay, so it would have said that 2 minus x would have to be less than 0 and 2 plus x would have to be less than 0. Okay, so two negatives, negative 4 and negative 2 make a positive 8. So negative x is less than negative 2. X would have to be greater than 2. And at the same time, x would have to be less than negative 2. Is that possible? So think about this on your number line. Is it possible? This is not an or statement, it's an and statement. We don't see a lot of and statements in math, but this is one of those circumstances, okay? So here we are. We have to be greater than 2 and less than negative 2. Well, there's no overlap here. So this, because this says and, this is impossible, okay? Okay, so there's no solution coming out of that. So we do get the same answer out of case analysis that we did by the graphical or logical approach. Okay, part B says, find the limit. Find the limit. Oh, come on. I was just trying to block that off. Okay, find the limit of ln 4 minus x squared as x approaches 2 from the left. Okay, so let's think about this. If I tried to do direct substitution, if I tried to put 2 in here, I'd get 4 minus 2 squared, which is equal to 0, which is not okay, right? It's not okay for a log to be 0. You can't, that's impossible. So direct substitution doesn't work. Okay, so then we have to try a different approach. What if we said let u equal the argument? Okay, then let's think about as x approaches 2 from the left, then what would u be approaching? Okay, what would u be approaching? U then would be approaching my 0 that I was just working on, 4 minus 2 squared. So u would be approaching 0. And what does this look like on my graph? So lots of these limits are just done where you have to visualize the graph. Okay, so now we have, instead of ln 4 minus x squared, we have ln u. What does the graph look like? Well, that's just my graph of ln u. Lucky for us. And so what's happening as u approaches 0? So now we're looking at the limit as u approaches 0 of ln u. Well, as u approaches 0, the graph is approaching negative infinity. That's the best way to do those limits. All right, a couple more examples. Find the domain of ln x minus 3 plus ln x. So we have two logarithmic functions here that are being added together, and we're asked to find the domain. I just realized one bad thing about this back here. My bad. I didn't actually write this in the formal domain. Let me add in my curly brackets. Malmstrom. Out of practice. Okay. Here we go. They really want to see you do proper notation at university, so I have been trying to provide you with that in the examples. So hopefully I didn't miss any other places. Okay. Because it says domain, it wants proper domain notation. So just make sure you pay attention to the wording. If it just said restriction, you'd get a little bit more flexibility on the notation piece. Okay, so when we're looking at logarithms that are being added together, then you have to look at each of those arguments, and we have another and statement. X minus 3 will have to be greater than 0, but it has to work for the entire function, which has this plus x. So, and the other argument, x, which is just x, has to be greater than 0. So when I go to solve the first argument, I get that x has to be greater than 3. And at the same time, x has to be greater than 0. So you get this and statement, and really it becomes who wins the battle, right? Just think about that number line again. We have our 0 and we have our 3. And when it's an and statement, it has to be true for both. So we're greater than 0 and we're greater than 3. And where is the overlap? Once we get greater than 3, that's the domain then for the entire function. So therefore, x such that x has to be greater than 3. X is an element of all reals. Of course, we can use the other notation, which would be 3 to infinity with open brackets. All right. Last thing, write as a single logarithm. So we're just going back to see what we remember from 30 and apply it to our natural logarithms. So we're going to use our power law and our quotient law and our product law all together in this question. So remember, product and quotient cannot be used until we have no coefficients. So the first thing I'm going to do is move those coefficients to become powers. Okay, so we have ln x squared plus ln 1 plus x cubed minus ln 2 plus x to the power 4. Bedmass rules apply. So I'm going to just do this from left to right. So I have a plus to start with, so that'll be the product law. So ln x squared multiplied to 1 plus x cubed minus ln 2 plus x to the power 4. And then I would have the quotient law. So then I would divide x squared 1 plus x cubed divided by 2 plus x to the power 4. And it really didn't ask us to do anything more. It didn't ask us to state the domain restriction with that. just asked us to simplify it. So there it is. That is the end of 8.3 lesson. So the next lesson, we'll look at the derivatives of the logarithmic function.